So welcome everyone. In the previous lecture, we discussed about construction materials. So in this lecture, we are also discussing about the remaining part in construction materials. So today class is on concrete. So basically, concrete is a construction material composed of cement, fine aggregate. Fine aggregate means nothing but sand, and coarse aggregates are gravel which is mixed with water, which hardens with the time. So concrete is basically a made up of three components here. One is the cement or lime, we can use, alternatively we use anything, and coarse aggregate nothing but gravel, and fine aggregate nothing but sand. With these three components and water, the concrete will be made. There are two sets of criteria that we must consider when making of concrete. The first one is the long term requirements of hardening concrete, and second one short term requirements. So here the long term requirements means the factors like strength, strength, durability. These two factors are important for long-term requirements of hardened concrete: strength and durability. Strength, the term that refers the ability of a material to resist failure. That is called as the strength. So this is the one of the important factor in making of concrete for long-term requirement. Another one is the durability. The term durability, it refers the property by which concrete possesses same strength throughout its lifetime without much of shrinkage and cracking is nothing but the durability. So durability is also important factor in long-term requirements of hardened concrete. Durability is the property by which concrete possesses same strength throughout its lifetime without much shrinkage and cracking. So if you see the factors that are affecting durability are water content and cement content. So these two factors that influence the durability. So the maximum cement content as per Indian standard 456/2000 is 450 kg per cubic meter. So this is one of the important thing we need to know while considering the cement concrete. So here we can see that there are two long-term requirements. One is strength, another one is the durability. So strength, the ability of a material to resist failure. The durability, it is a property by which concrete possesses same strength throughout its lifetime without shrinkage and cracking. So the durability is affected by the two factors. One is the water content and cement content. The maximum cement content is, as per IS 456/2000, is the 450 kg per cubic meter. Whereas the minimum cement content, it is based on the exposure conditions. We know the exposure conditions like mild, moderate, severe, very severe, and extreme. So these five conditions called as the exposure conditions like mild, moderate, severe, very severe, and extreme. So based on these five exposure conditions, the minimum cement content is based on. So this is about the long-term requirements. The long-term requirements of hardened concrete is two things. One is the strength, another one is the durability. Next, we are going to discuss about the short-term requirements. Generally, the short-term requirement is nothing but the workability. So that is about the short-term requirements is the workability. So let's discuss about the workability. The term workability, the term workability, it refers to the amount of internal work required to produce full compaction is nothing but the workability. So before going to discuss about the workability, there is a term called consistency. Consistency and workability both are influential to the hardened concrete. Whereas workability is the amount of internal work required to produce full compaction of the concrete, but as consistency, it is a term to indicate the degree of fluidity or the degree of the mobility. So that is the difference between the consistency and workability. So workability is the amount of internal work required to produce full compaction, whereas consistency is the term that indicates the amount of degree of fluidity or degree of mobility. So if you consider the workability, the factors helping concrete to have more lubricating effect to reduce internal friction for helping easy compaction. So the factors that influencing workability are mainly water content. Generally, as per Indian standard 456/2000, the water content like potable water should not be less than 6 pH value. So the factors influencing workability are: one is the water content. As per Indian standard 456/2000, the water content like potable water should not less than 6 pH value. Whereas if you see the permissible limits of solids like organic solids, that is 200 parts per milli, 200 ppm. Whereas for sulfate SO3, the water content permissible limits of solids will be 400. Whereas for chlorides, that will be 2000 milligrams per liter or parts per million, that is ppm. So these are the some of the important factors that influence the water content. So the water content should not be less than 6 pH value as per IS 456/2000, and the permissible limits of solids like organic will be 200 ppm. Factor affecting workability are mixed proportions, generally the concrete is having designated by some grades. The mixed proportions, these will influence us. Generally we have grade of concrete starting from M5, M7.5, M10, M15, M20. Here M stands for mix and phi stands for compressive strength of concrete in Newton per mm square or megapascal. So that represents the units of a compressive strength. Generally the strength is represented in terms of Newton per meter square or megapascal. So that is equal value. So here M stands for mix and phi stands for 5 Newton per mm square compressive strength that represents. So these are the grades of concrete. Basically we are using here, using in mixed design. If you see the proportions, the proportions of cement, fine aggregate and coarse aggregate, for M5 the ratio will be 1:5:10, whereas for M7.5 the ratio will be 1:4:8, whereas for M10 the ratio is 1:3:6. For M15 the ratio is 1:2:4. For M20 the ratio is 1:1.3. Here if you see the M20 grade of concrete is generally in reinforced cement concrete, that RCC, the minimum grade of concrete that is used as a M20. This is a very important thing. In reinforced cement concrete the minimum grade of concrete is nothing but the M20. It represents 1:1.5:3. Here represents 1 part of cement, 1.5 part of fine aggregate, that is nothing but sand, and 3 parts of coarse aggregate. If you try to prepare M20 grade of concrete, if you take 1 kg of cement, then you have to take 1.5 kg of sand and 3 kg of gravel. And the water content, water by cement ratio we say, that is nothing but the, based on the exposure conditions, it will be from 0.45 to 0.5. It will be based on the exposure conditions like mild, moderate, severe, very severe and extreme conditions. So these are the some of the important things in mixed proportions. Mixed proportions is nothing but, here we are discussing about the grades. This is the basic grades we used in the concrete making: M5, M7.5, M10, M15, M20. Here M stands for mix and phi stands, that denotes the compressive strength of concrete in Newton per mm square. If you see the proportions of a grade of concrete M5, 1:5:10. Here 1 represents cement, 5 represents fine aggregate, that is nothing but sand, 10 represents coarse aggregate, that is nothing but gravel. If you see the water content for concrete mix, that will be from 0.45 to 0.5, that is water by cement ratio. It will be depend upon the exposure conditions like mild, moderate, severe, very severe and extreme. So these are all about the workability second factor, that is a mixed proportions. If you talk about the third factor, that is about size of aggregates. Generally, the aggregates we are using coarse aggregate like gravel. Another one is the sand. There are two types of aggregates. One is the coarse aggregate, another one is the fine aggregates. Here, coarse aggregates means nothing but gravel. Generally, the gravel is having the size of greater than 4.75 mm. But for construction purpose, mainly in RCC, that reinforced cement concrete, the nominal sizes of coarse aggregates are 10 mm, 15 mm and 20 mm are used. The maximum size of coarse aggregate that is used in reinforced cement concrete in RCC is nothing but the 20 mm. This is very important thing. In RCC, the maximum size of coarse aggregate is nothing but the 20 mm. If you try to see the fine aggregates, that nothing but the sand. Sand, we can say sand is having the size of less than 75 microns. So less than 75 microns, that is classified as the sand. It can be used in construction purpose. Okay, so these is all about the size of aggregates. One is a coarse aggregate, that is a gravel. It is greater than 4.75 mm. The main maximum nominal size is 20 mm. Whereas fine aggregates, that is sand, that should be less than 75 microns. Next, another factor that influencing workability is the shape of the aggregate. Generally, there are different types of shapes available for aggregates. One is a rounded, angular, flaky. Another one is elongated. Another one is irregular. So these are the different types of shapes of aggregates are available. One is a rounded aggregate, angular aggregate, flaky, elongated, and irregular. If you talk about the rounded aggregate, generally the rounded aggregate, it gives good workability. Good workability, low water demand, and poor bonding. Whereas if you see the angular it increases water demand. Whereas rounded aggregate is decreases water demand, it increases water demand. Another one is the flaky. Flaky, it is aggregate stacks give workability problems. So flaky is not preferred. Whereas the elongated. Elongated also may lack cohesion and require increased fines. So elongated also is not preferred. If you see the irregular is the low workability and low water demand, but it is not also economical. So based on these shapes, rounded is the most economical. It gives good workability and low water demand. But the thing is that it is having some poor bonding. But if you see the angular it increases water demand but gives good bond. So in construction, the most preferred one is the angular. These are also some of the important bit based on the rounded and angular. Rounded it gives a low water demand, but angular it increases the water demand. But the thing is that rounded it gives the poor bonding, angular is giving the good bonding. So that is the shape of the aggregates. The important one is the angular. Angular that gives the good bonding to the concrete. Next, another factor we are discussing is nothing but the admixtures. So admixtures are the chemical compounds used for improving the characteristics of concrete, such as workability, setting time, etc. So admixtures that play a very crucial role in setting of concrete and workability. Admixtures are the chemical compounds used for the improving the characteristics of concrete, such as workability and setting, without affecting the strength of concrete. There are three different types of admixtures are there. One is the retarders, another one is the accelerators, another one is the plasticizers. If you see the retarders it delays the setting time. Delays the setting time of cement, particularly in hot climates for certain time. Example we can say that is gypsum. Very important one, gypsum. So retarders it delays the setting of cement, particularly in hot climates for certain minimum time. So gypsum is one of that component. Accelerators. Accelerators accelerates the setting process, particularly in cold climates. It delays, retarders delays the time, it accelerates. So it delays, it accelerates. We can say accelerators as simple as calcium chloride, CaCl2. This is one of the important one. Next, plasticizers. Plasticizers are air entraining agents, improve the workability of concrete in case of rich mixes and congested reinforcement. So this is the one of the important. Plasticizers are entraining agents, improve the workability of concrete in case of rich mixes and congested reinforcement. So generally these plasticizers act as a air entraining agents that improves the workability. So these also some of the important factors that affecting workability. Majorly we say that the retarders and accelerators that influence the workability. So example for retarders is gypsum, for accelerators that is calcium chloride. So these all about that. So next we'll discuss about the segregation and bleeding. Segregation, it refers to a separation of the components of fresh concrete resulting in a non-uniform mix. This can be seen as separation of coarse aggregate from mortar caused from either the settling of heavy aggregate to the bottom or the separation of the aggregate from the mix due to improper placement. So segregation refers to a separation of the components of fresh concrete resulting in non-uniform mix. So this is about the segregation. Generally, segregation is caused when coarse aggregate is separated from fine materials, resulting in large voids, less durability, less strength. Some rules of thumb are developed for deciding the quantity of water in concrete. But that is the weight of water is equal to 28% of cement plus 4% of total weight of aggregate. So these are some of the rule of thumb we used to decide the weight of water is equal to 28% of weight of cement plus 4% of the weight of total aggregate. Another thumb rule is the 30% of weight of cement plus 5% of the weight of total aggregate. So these are the two things we consider: 28% of cement content plus 4% weight of the total aggregate, or 30% of the cement content plus 5% of the total aggregate for weight of the water. If you see the factors that influencing the segregation are the larger maximum particle size like 25 mm, that is a larger particle size, and proportion of the larger particle. Another factor is affecting the segregation is the high specific gravity of coarse aggregates. Another factor is the decrease in the amount of fine particles. Another one is the particle shape and texture also influencing the segregation. And finally, the water by cement ratio. So these are some factors that increase the segregation: water by cement ratio, particle shape and texture, decrease in the amount of fine particles, high specific gravity of coarse aggregate, large maximum particle size and proportion of the large particles. To prevent segregation, good handling and placement techniques are most important in prevention of segregation. So these about the segregation, and then we discuss about the bleeding. So bleeding is defined as the appearance of water on the surface of concrete after it has consolidated but before it is set. Since mixing water is the lightest component of the concrete, this is a special form of segregation. So, bleeding is generally the result of aggregates settling into the mix and releasing their mixing water. Some bleeding is normal for good concrete. So that is about the bleeding. So bleeding, it will be appearance of water on the surface of concrete after it has consolidated. So that is about the bleeding. If bleeding becomes too localized, channels will form resulting in craters. The upper layers will become too rich in cement with a high water by cement ratio, causing a weak porous structure. Salt may crystallize on the surface, which will affect bonding with additional lips of concrete. This formation should always be removed by brushing and washing the surface. So these are about the bleeding. Bleeding may be reduced by increasing cement fineness, increasing rate of hydration, using air entraining admixtures, reducing water content. So let's have the brief about the segregation and bleeding. Segregation means separation of components of fresh concrete resulting in a non-uniform mix. Whereas the bleeding is appearance of water on the surface of concrete after it has consolidated. Bleeding can be reduced by increasing cement fineness, increasing rate of hydration, using air entraining admixtures, reducing the water content. For fresh concrete to be acceptable, it should be easily mixed and transported. Coming to measurement of workability. Workability means the amount of internal work required to produce full compaction. A term applied to many concrete properties can be adequately measured by three characteristics. One is the compatibility, mobility, and stability. Compatibility, the ease with which the concrete can be compacted and air void removed. That is the compatibility, air void removed. Mobility, which concrete can flow into forms and around reinforcement. Another one is the stability, ability for concrete to remain stable and homogeneous during handling and vibration without excessive segregation. So these three characteristics are very important for workability: compatibility, mobility, and stability. Next, coming to the measurement of workability. So generally there are different types of tests will be performed to know the workability of concrete. One is the slump test, one is the compaction factor test, VB consistometer test, flow test. Another one is also there. There is a key ball test. So except slump test and all are field test. Slump test, slump test is a field test. Remaining all are laboratory test. So let me start with slump test. Slump test is most commonly used method for measuring the consistency of concrete. Consistency of concrete which can be employed either in laboratory or at site of work. So slump test is maybe it can be used in both a laboratory or at site of work, but mainly the slump test is used to measuring consistency. It is not suitable method for very wet or very dry concrete. So it is not suitable for very wet or very dry. It does not measure all factors contributing to workability. If it is the slump test, here it is a slump cone. The diameter of the rod is generally 16 mm and its length is 60 centimeters. If you see the slump test here, the top diameter is 10 mm and bottom is the 20 centimeters. These are 10 centimeters. These are 20 centimeters, and the height of the slump is 30 centimeters. So this is very important. The top diameter of the slump is 10 centimeters, the bottom diameter is 20 centimeters, and height of the slump is 30 centimeters. Whereas the rod which is used for compacting of concrete in slump cone, the rod is having 60 mm diameter and 60 centimeter length. So here little bit confusion will be there. The slump cone will be 10 centimeter top dia, 20 centimeters bottom dia, and 30 centimeter height for slump cone. Whereas for rod, there will be a 16 mm diameter and 60 centimeter height. The strokes to be given for ramming vary from 20 to 30. Okay. So these about the slump test. In the slump test, we can see three types. One is the true slump, shear slump, and collapsing. While measuring the consistency of concrete, these three will occur. Next, generally the recommendations will be made for here type of the concrete and slump. Generally for concrete, for road construction, that is 20 to 40 mm slump we prefer. For beams and slabs, we prefer 50 to 100 mm. For normal RCC work, the slump will be 80 to 150 mm. For mass concrete, 25 to 50 mm. Concrete to be evaporated 10 to 25 mm, and impermeable work is 75 to 120. Here, very important one is the road construction and beams and slab and normal RCC work. For normal RCC work, it will be 80 to 150 mm. This is a very important slump for concrete work. Next, another test one is the compaction factor test. In the compaction factor test, the degree of workability is measured. The degree of workability is measured in terms of internal energy. In terms of internal energy required to compact the concrete thoroughly. So, in the compaction factor test, the degree of workability is measured in terms of internal energy required to compact the concrete thoroughly. If you see the operator's compaction factor, here the hopper clamp and conical hopper, another one is a cylinder. In three stages, the concrete will be dumped here. Okay, so if you see the compacting factor and slump values, this table is very important for most of the competitive exam and gate exam. In this table, definitely two questions we can expect. For degree of workability very low, the slump is nothing here. For low, 25 to 75 mm. For medium, that is 50 to 100 mm. For high, that is 100 to 150 mm. This is very important for slump and the degree of workability. The questions will be asked many times. If medium workability, then what is the slump value? So we can pick up here 50 to 100 mm. For low workability, that's 25 to 75 mm. For high workability, that is 100 to 150 mm. For very low and very high, there is no slump value. We need to observe here importantly. Similarly, the compacting factor, that is the small operators, is very important here. The compacting factor for very low workability is 0.78. For low workability, that is 0.85. For medium workability, that is 0.92. And for a very high, that is 0.95. A compaction factor of 0.95 represents flowing concrete having very high workability, whereas that is 0.92 that represents plastic concrete having medium workability, whereas the 0.85 represents stiff plastic concrete having low workability, whereas 0.78 represents stiff concrete having very low workability. So these things very important. The small operators, you have to check it here. Okay, many times in the competitive exams gate will be asked here. Uses for which concrete is suitable here. For very low concrete, the rods vibrated by power operated, and for low rods are vibrated by hand operated. Here power operated machines, here hand operated machines. For medium, less workable, medium compacted. For high, for sections with congested reinforcement. Very high, the flow table test is more suitable. So these are the some of the degree of workability with relationship with the slump and compacting factor. When you have the medium degree of workability, we have the slump value of 50 to 100 and compaction factor of 0.92. For high workability, we are having compacting factor of 0.95 and slump value in between the 100 to 150. So these are the some of the important values that can be used many times in competitive exams. Next, so up to we discussed about the slump cone test and compaction factor test. In a next on the slide, we're discussing about the VB consistometer test. VB consistometer, it is a good laboratory test to measure indirectly the workability of concrete. So in the previous compaction factor test and slump test, it measures directly the workability. The compacting factor test is designed primarily for use of the laboratory, but it can also be used in the field. But slump test also used for both laboratory and field. Here VB consistometer is indirectly measuring the workability of concrete, but slump and compacting factor that measures directly the workability of concrete. So this thing you need to understand here. And VB consistometer is a good laboratory test to measure indirectly the workability of concrete. This test consists of a vibrating table, metal pot, a sheet metal concrete, standard iron rod. The time required for the shape of concrete to change from slump concrete shape to cylindrical shape in second is known as a VB degree. This is a very important thing we need to understand here. The time required for the shape of concrete to change from slump concrete shape to cylindrical shape in second is known as VB degree. This method is very suitable for very dry concrete whose slump value cannot be measured by slump test, but the vibration is too vigorous for concrete with a slump greater than about 50 mm. So this is one of the important factor we need to understand here. So this is all about the VB consistometer. Next we discuss about the flow table test. Flow table test is a laboratory test which gives an indication of the quality of concrete with respect to consistency, cohesiveness, and the proneness of segregation. The spread of flow of the concrete is measured and this flow is related to workability. So mainly the flow test is an indication of the quality of concrete with respect to the consistency and cohesiveness. So mainly if you see the types of the test, slump cone test, compaction factor test, VB consistometer test and the flow test. These are all the tests performed to know the degree of workability of concrete.